Okay, here's the next identity. And if you do the multiplication, you're going to reach here and derive this one, okay? And it is x squared plus the sum of r and s here times x plus the product of r and s. Okay, so let's first give you an example of multiplying in this way. For instance, x plus 2 times x plus 3, calculating it, without doing the multiplication and with using this would be x squared plus r and s here are 2 and 3 plus the sum of 2 and 3, which is 5x plus the product of 2 and 3, which is 6. Okay, now let's have a factoring example using this identity. Let's factor x squared plus 9x plus 20. Now it is not, let's first check if this is in the form of the perfect square identity. If it be, so we should have two square terms. So let's write it as a square. The square root of 20 square. Okay, and if you don't know what is the square root of 20 and are not familiar with this notation, it is just a number which square would be 20. Okay, and now if this be in the form of the perfect square identity, this term, the 9x, should be double of the product of x and this one. So double of the product would be 2 the square root of 20 times x, but it is not equal to 9x. Okay, so it is not in the form of the perfect square identity. So let's see if we could use this identity to factor it. You see here the coefficient of x is r plus s and the constant is r times s. So here the coefficient of x is 9 and the constant is 20. So we should find r and s, which sum would be equal to 9 and which product to 20. Okay, it's not hard. R and s, equals to, or let's say r equals to 4 and s to 5. So their sum would be 9 and their product would be 20. So this would be equal to x plus 4 times x plus 5. Let me write it. Plus 5. Let's have another one. Let's factor 4x squared minus 2x minus 20. It doesn't seem to be in the form of this identity, in the form of this polynomial, okay, because the coefficient of x here is 4, but here is 1. But here 4, we could rewrite 4 as 2 squared. 2 squared. So this would be 2x, the whole thing squared, minus 2x minus 20. And now it seems to be in the form of this because we got the coefficient of the square term is 1 here also. Instead of x, we got 2x. Okay, so let's see if we could factor it using this one, this identity. And first, let's take 2x to be equal to something like y. And rewrite the polynomial. The polynomial would be equal to y squared minus y minus 20. And here we should find R and S, which sum would be equal to minus 1 and which product to minus 20. So R plus S should be minus 1, R times S minus 20, and they are minus 4, easily minus 4 and 5, sorry, minus 5 and 4, which sum is minus 1 and which product minus 20. So this would be equal to, let me make some space, y minus 5 times y plus 4. And since the original polynomial is in terms of x, so after factorizing it, it should also be in terms of x. We plug 2x into y here, 2x minus 5 times 2x plus 4. Okay, let's have another one. Let's factor y to the power of 4 minus 3y squared plus 2. Okay, again, it is not in the form of the perfect square identity. You could check it if you don't believe me. And it doesn't seem to be in this form also, but it is nothing but y squared minus 3y squared plus 2. So let's take y squared to be equal to, say, x. So this would be x squared minus 3x plus 2. And now it seems to be in this form. So let's find R and S, which sum would be minus 3. Now, which sum would be minus 3, and product would be 2. Again, they are minus 1 and minus 2, which sum is minus 3 and product is 2. So this would be x minus 1 times x minus 2. Now let's write it in terms of y. So x is y squared, here y squared, also here y squared. And now we could factorize this again also. So using each parenthesis, using the difference of squares identity. So the first parenthesis would be y minus 1 times y plus y, and the second one would be y minus the square root of 2 times y plus the square root of 2. Okay, that's it. Now don't miss the next example in the next video. Thank you.